So chapter 16, section 1, Thermochemistry. Thermochemistry is the study of transfers of energy as heat during the chemical reaction or physical change. So in chemical reactions or physical change, they may absorb or release energy as heat when occur. So the study of energy absorbed or released during the chemical reaction or physical change, it's called thermochemistry. So the amount of energy transferred as heat depends on if you have 1 drop of water in your hand or 1 drop of acetone or alcohol in your hand. Which of these will dry faster? Today we are using hygiene. If you add hygiene to your hand, you observe that it will dry faster than if you add water, for example, in your hand. So the amount of energy transferred as heat depends on the nature of substance. It depends on the intermolecular forces between molecules in the compound. So the first factor, nature of substance. The second one, if you have, for example, 1 gram of ice or 100 gram of ice. So in this case, A, you have 1 gram of ice, and B, 100 gram of ice. In which case, it needs more energy to melt, 1 gram or 100 gram. So 100 gram need more energy to melt. So the second factor is mass of substance. Three, change in temperature. For example, if you have 10 gram of water, and in the second case you have 10 gram of water, and in the first case you have to increase the temperature from 25 Celsius to 50 Celsius. And here, in the second case, you want to increase the temperature from 25 Celsius to 95 Celsius. So which of these need more energy? If you want to increase the temperature by 25 Celsius, or if you want to increase the temperature by 40 Celsius. So here, you need more energy to increase the temperature from 25 to 95. So energy transferred as heat depends on the change in temperature. So the three factors are nature of substance, mass of substance, and change in temperature. So what is the rule? Q equal specific heat times mass times delta T. So Q, energy as heat, and here we talk about the first factor, nature of substance. So here specific heat. So energy depends on the nature of substance and depends on the mass and depends on the change of temperature. So here, what is the unit for energy? Joule. The unit for mass is gram. And the unit of temperature Celsius or Kelvin. So it depends on the question. If Celsius, don't change to Kelvin, or if the question Kelvin, don't convert to Celsius. So what is the unit of specific heat? So Q, heat, or energy as heat, specific heat times mass times change of temperature, over mass times delta T over times delta T. So specific heat equal Q over mass times delta T. So what is the unit for energy? Joule. The unit for is a gram, and the unit for T is Celsius or Kelvin. So the unit for specific heat equal joule per gram times Celsius, or joule per gram times Kelvin. So we write the unit as Celsius or Kelvin, depends on the temperature in the question, of the unit of the temperature in the question. So again, if you have physical change and you want to calculate the heat transferred, you have to use this rule. Energy as heat, it depends on the nature of substance, specific heat, it's given in the question, times mass of the substance times change of temperature. So example number 1. This is the rule. Example, the heat needed to increase the temperature of 20 gram water from 20 Celsius to 25 Celsius is. So the specific heat of water is 4.18 joule per gram times Celsius. So the question asks about heat. Specific heat is given in the question. Mass is given in the question. And delta T is given in the question. So Q equal heat equal specific heat times mass times delta T. Specific heat is given in the question, 4.18 times mass is 20 times delta T. Delta T means change in temperature. So from 20 to 25, the change is 5 Celsius degree. So, which is equal 4.18 times 20 times 5, 100. So when you multiply 4.18 times 100, you have to move the decimal 2 units. So the answer is 418. What is the unit for heat? Is joule. Okay, so now another question. a 4-gram sample of glass was heated from 274 Kelvin to 314 Kelvin. A temperature increases of 40 Kelvin and was found to have absorbed 32 joule of energy as heat. So what is the specific heat of glass? So here a 4-gram, so mass is given in the question, was heated from 274 to 314 Kelvin. A temperature increases of 40. Here direct in the question they calculate delta T and was found, so here delta T and here mass, and was found to have absorbed 32 joule. So here heat Q. What is the specific heat? What is the rule? Energy as heat equals specific heat times mass times delta T. So energy as heat 32 equal specific heat, you have to calculate it, times mass equal 4 times delta T 40. So 32 equal specific heat times 4 times 40, 160 over 160 over 160. So specific heat equal 32 over 16, 2. So 2 over 10, which is equal 0.2. What is the unit? If you remember, specific heat equal energy over mass times delta T. So energy, joule, per mass, like gram, times delta T. Here in the question, they use Kelvin, so per Kelvin. So again, thermochemistry is the study of energy transferred as heat during a chemical reaction or physical change. So if you have physical change, this is the rule. Energy equals specific heat times mass times delta T. Now, if you have chemical reaction, so energy of reactions. Energy of reactions, it's called enthalpy of reaction. The abbreviation for enthalpy, now the symbol for enthalpy, delta H. So delta H means energy absorbed or released during the chemical reaction. So what is the rule? energy absorbed or released equal energy of products minus energy of reactants. So, in which case the answer will be negative. So here the rule delta H energy equal energy of products minus energy of reactants. So when energy of reactants greater than energy of a product, so the answer is negative. So here delta H is negative, in which case when the energy of reactant greater than energy of product. So in this case of reactions, they are called exothermic reactions. The general formula for exothermic reactions, reactant, and here product, and the energy with product. So in exothermic reactions, they are the reactions that released energy. So this is the general formula of exothermic reaction. If you want to draw a plot between the energy or enthalpy of reactant and product, which of these has the higher energy? Reactant. So the graph is here the energy of reactant and here the energy of product. So energy released during this reaction, it's called delta H. How to get if the reaction is exo or endo from chemical equation? So here an example. For example, 2 hydrogen gas plus 1 mole of oxygen gas produced 2 mole of water gas plus 483 kilojoule. So in any chemical reaction, if the energy with a product, so it's an exothermic reaction. Or you can write this equation as 2 mole of hydrogen gas plus 1 mole of oxygen gas produced 2 mole of water gas, delta H equal energy. Here it's an exothermic reaction, so the sign of delta H is negative. So here minus 483 kilojoule. So in any chemical reaction, if the energy with the product or if the sign of energy is negative, so it's an exothermic reaction. So here, in which case the answer will be positive, is positive. When energy of a product greater than energy of reactant. So here positive when the energy of a product greater than energy of reactants. So in this case, when energy of a product greater than energy of reactant, it's called endothermic reaction. So this reaction need energy or absorbed energy to, okay. So the general formula, reactants plus energy, because this type of reactions need energy to occur. So product. So the reverse. Here, if you want to draw a plot to show the energies of product and reactant, so product higher than reactant. So here the reactant lower in energy and product higher in energy. So delta H absorbed in this reaction. So this is the delta H or energy absorbed. So how from chemical equations you can get the reaction that the reaction is endothermic? So the energy must be with reactant. For example, 2 moles of water plus 483 kilojoule. It will give 2 mole of hydrogen plus 1 mole of oxygen gas. So here the energy with reactant. So it's an endothermic reaction. Or when delta H of the reaction is positive, it means that it's an endothermic reaction. 2 mole of water just decomposed to 2 mole of hydrogen gas plus 1 mole of oxygen. So delta H equal 483 kilojoule. So here the sign is positive. Positive means endothermic reaction. So how to calculate? How to use this rule to calculate the energy, the amount of energy absorbed or released from the reaction? You have to use his law. So the over, state that the over all enthalpy change in a reaction is equal to the sum of enthalpy changes for the individual steps in the process. Which means if you have a chemical reaction and it happened by 2 steps, for example, so the overall energy of the reaction equal to the sum of the energy change for the individual steps in the process. So again, if you have chemical reaction done by 2 steps, So the energy for the reaction equal to the summation of energy for these two steps. For example, what is delta H for the reaction A plus B to produce W plus M, for example? If this reaction occurs by two steps, A plus B to produce C, delta H equal 100 kilojoule per mole, and C decomposed to W plus M, delta H equal minus or negative 40 kilojoule per mole. So A minus 140 kilojoule, B minus 60, C 60, D 140, and E 230. Which of these the correct answer? So here you have this equation. You have to calculate delta H for this equation. You have these reactions. You have to find how to organize or rearrange these reactions to get this reaction. So if you add if you add these reactions to each other, you can get this reaction. Here A plus B equal C, and C decomposed to W plus M. Here delta H equal 100 kilojoule per mole, and here delta H equal minus 40 kilojoule per mole. If you add these two reactions with each other, so you have to add the reactants with each other. A plus B plus C produced C plus W plus M. Here you add the reactions, so you have to add the energies. So 100 minus 40 equal delta H for this reaction equal 60 kilojoule per mole. Here you have C in the reactant and product, so you can delete it. So A plus B equal or produce W plus M. Delta H for this reaction 60 kilojoule per mole. So here you get the reaction you want in the question. So again, the overall enthalpy for this reaction is the summation for enthalpy change for the individual steps in the reactions. So here you add these reactions to each other to get this reaction. So you have to add the enthalpy change to each other. So the answer is 60. Another example. Before example, you have to note that any change of the reaction, so delta H changes. Yani for example, if the reaction is reversed, so delta H also reversed. You have to flip the charge. And you have to note that if the reaction is multiplied, so delta H also multiplied. نشوف كيف. Example. What is delta H for the reaction A plus B 2M plus 2W? If A plus B 2C, so delta H equals 70 kilojoule, and M plus W produce C, and delta H equal 30 kilojoule per mole. The idea is you have to rearrange these reactions to get this reaction. And if you change anything of this reaction, if you reverse, so delta H reverse. If you multiply by any coefficient, so delta H multiplied by this coefficient. So how to rearrange these reactions? Here A and B in the reactants, and here A and B in the reactants. So don't change this reaction. A plus B produced 2C. Delta H equal 70 kilojoule per mole. Now here M and W are in the product. Here M and W are in the reactant. So the first step, you have to reverse the reaction or flip the reaction. So here C produced M plus W, so delta H, you have to change the sign. Instead of positive 30, so negative 30 kilojoule per mole. This is the first change. Okay, here in the reaction you have 2M plus 2W. Here you have M plus W, so you have to multiply the reaction by 2. So if you multiply here by 2, also here you have to multiply by 2. So delta H equal minus 60. So now 2C produce 2M plus 2W, delta H equal minus 60 kilojoule per mole. Now if you add these reactions to each other, you can get the original reaction. So here 2C are in the product and here 2C are in the reactant. You can delete it. So A plus B produce 2M plus 2W, which is like this reaction. So here you have to add delta H to each other. 70 minus 60 equal 10 kilojoule per mole. So again, the idea, you have to rearrange the reactions to get the reaction in the question. And any change in the reaction, you have to change delta H. The last example. What is delta H for the reaction carbon as graphite to carbon as diamond? If the here the delta H equal minus 394 kilojoule per mole, and in this reaction delta H is minus 396 kilojoule per mole. So here C graphite is in the reactant. So here in the reactant, don't change this reaction. So delta H equal minus 394 kilojoule per mole. Now here, diamond, carbon as diamond in the product and here in the reactant. So you have to flip or reverse the reaction. So carbon dioxide, carbon as diamond plus O2, delta H equal. If you reverse the reaction, so the sign must be reversed. So instead of minus or negative 396, it's positive. So you have here now add these two reactions to each other. Here carbon dioxide in the product and here in the reactant you can delete it, and oxygen reactant and here product you can delete it. So carbon as graphite produced carbon as diamond, delta H, you have to add negative 394 to 396, so which is equal to kilojoule per mole. So again, to get the energy of reactions, you have to rearrange the reactions to get the original reaction in the question, and any change of the reaction, delta H must change. Thank you.